Hello, we are talking about section 9.2 today, and that is talking about linear regression. Here we go. Let me get this in presentation mode. Okay, so linear regression. After verifying that the linear correlation between two variables is significant and linear, the next step is to determine the equation of the line that best models the data. So I've shown you how to do this in the technology already. In the last video on 9.1 on correlation, I showed you how to get that linear regression line. And the more advanced, there is an advanced statistical report for this, but because we aren't covering the majority of what's in that report in this section, we're just covering the equation of the line. Please refer to the 9.1 video on correlation coefficient to see how to get this regression line in Rguroo. So this line is called the regression line, and its equation can be used to predict the value of y for any given value of x. So essentially, if we wanted to predict, talking about the Old Faithful, and we'll go back to that example so I can practice with it using the regression line that was created in Rguroo, we could place a duration of an eruption time into the linear equation and predict how long will it be before the next eruption based on that data? And we'll practice with that in a little bit. So for each data point represents the difference between the DIs, the distance represents the difference between the observed value and the predicted value. So remember, if you're looking at this regression line, it doesn't hit all the dots. So when we're predicting values, we're not actually predicting. We're predicting a guess, our best guesstimate, but the point can be slightly above or below the line. So it's not guaranteed that that's the exact value. So here we can see that this is the best fit line. It's found by taking these distances and minimizing the distances. So if this line was way up here, the distance to this point would be huge, and that would not be good. So the least squares regression, what it does is it takes these distances and it minimizes it to get the best fit line. These differences are called residuals and can be positive, negative, or zero. So above the line would be positive, below would be negative, zero would mean the dots have actually landed directly on the line. The regression line, also known as the line of best fit, can be found using a very complicated formula. We're using statistical software. We are not doing this out by hand, but it's just a y equals mx plus b. Once you find the slope and the y-intercept, that's what we're using to make predictions. So let me pause here and head back to, actually, you know what? I am just going to show you. Yeah, let me, just for review, let me go back to my Rguroo screen. Here we go. So this is what we did in the last video. We imported the data, we went to plots, we went to scatter plot, we filled out this basic screen. We said, hey, we're using our Old Faithful data. We identified the X and the Y variable. We wanted the least squares regression line, which is what we just saw in the PowerPoint. And I want to show the correlation in the equation. And this is what it gave me. So this equation is how we can predict the time between eruptions based on a duration of eruption. So for example, let me show you. So we're looking right now at our regression line. We saw the slope and we saw the y-intercept. So the slope, M, Rguroo told us that it was 12.481. and the y-intercept was 33.683. So if I was to write the linear regression line, the equation would be, we can predict y, which is the time between eruptions, by 12.481 times x, x being the duration time that the Old Faithful has just erupted for, plus the y-intercept of 33.683. So let's say, for example, we are told that Old Faithful just erupted for a duration of 20 minutes. And the question is, when do we predict the next eruption to be? So we would do, okay, y equals 12.481 times 20 plus 33.683. So if we type this into our calculator or into Excel or any calculator really. So I am typing in 12.481 times 20 plus 33.683. You can't see my calculator, but it's right here. And I press enter. Then I see that if Old Faithful is erupting for a duration of 20 minutes, then we can expect 283.3 minutes before the next eruption. Now, maybe that is way too hard for me to understand how long that is. So I might want to interpret this into hours instead of minutes, since it's a very long minute. So in order to convert minutes into hours, let's divide by 60 minutes, because there's 60 minutes in an hour. So I divided by 60, and I get 4.7 hours. So about 4.7 hours, I would be expecting Old Faithful to erupt again. Let's get back to the PowerPoint. So that's the regression line, and that's how we can use it to make predictions. Okay, slope, y-intercept, predicted value. We just talked about all this stuff. Okay, there's the old, oh look, the Old Faithful data has made its way back in here, so I guess I wasn't too far-fetched with using the same example. This is in Excel or the calculator, but I showed you guys how to do this in Rguroo, which is our statistical software we'll be using this semester. And our regression line, and we can use it to make predictions. So the regression equation for the gross domestic products and carbon dioxide emissions, we talked about that data in 9.1 as well. This is if we copied the data from 9.1 into an Excel sheet, uploaded it into Rguroo, or technically we can copy it right into Rguroo, which I'll show you eventually how to do that. Right now we're learning how to upload data sets. Then we can predict $1.2 trillion is the X variable. We place it right in for X and predict the Y, and so on. And here is the work done out with doing predictions for those three values. Okay, and that concludes our basic knowledge on linear regression. We will be diving into those residuals, residual plots, normality. All of that stuff is up and coming. It's just not yet. So this concludes 9.2 linear regression.